Changes have been identified in the brains of migraine sufferers. Hope for new therapies. Migraine sufferers have specific changes in the brain, new research shows. Using ultra-high-resolution MRI, researchers found that peривascular spaces in the brain are significantly enlarged in patients who experience both chronic and episodic migraine. These findings may open up new avenues for further research into the treatment of this devastating disease. Scientists from the University of Southern California in Los Angeles have identified enlarged peривascular spaces in the brains of migraine sufferers. Peривascular spaces, also called Virchow-Robin spaces, are fluid-filled spaces surrounding blood vessels in the brain. They are most often located in the area of the basal ganglia, in the white matter, in the thalamus, midbrain, cerebellum, hippocampus and along the visual pathway. Peривascular spaces are influenced by several factors, including abnormalities in the blood-brain barrier and inflammation. Enlarged spots can be a signal of many diseases, including dementia or hypertension and, according to new research, they also play a role in migraines. The only question is whether this mechanism is a result or a cause of the disease. The researchers' findings, presented at the 108th meeting of the Radiological Society of North America, may represent an unexplored avenue for future research. Perhaps this will help us develop effective therapies for migraines. Migraine is a common, often debilitating condition that includes severe, recurring headaches of varying severity and frequency. Migraines can also cause nausea, weakness, and photophobia. Sometimes there is also excessive sensitivity to sounds and smells. In the case of migraines, there is the so-called aura, which is characterized by scotomas, visual field defects, paresthesia, paresis or aphasia. According to the American Migraine Foundation, more than 37 million people suffer from migraines in the United States alone. In people with chronic and episodic migraine without the so-called aura, there are significant changes in the peривascular spaces in an area of the brain called the midsemi-oval. These changes have never been reported before, said Wilson Zhu, a doctoral student at the Keck School of Medicine at the University of Southern California in Los Angeles and co-author of the study. Peривascular spaces are part of the brain's fluid removal system. Studying how they contribute to migraine may help us better understand the complexity of its development, he added. Zhu and his colleagues wanted to see if enlarged peривascular spaces had any connection with migraine. They used ultra-high field MRI to compare structural microvascular changes in different types of migraine. To our knowledge, this is the first study using ultra-high-resolution MRI to investigate microvascular changes in the brain caused by migraine, particularly in the peривascular spaces. Because this type of study can produce much higher resolution and better quality images of the brain than other types of MRI. It can be used to show much smaller changes occur in brain tissue after a migraine, Zhu said. The study involved 10 people with chronic migraine, 10 with episodic migraine without aura, and 5 healthy volunteers from the control group. The study participants were aged 25 to 60. Analysis of MRI scans showed that the number of enlarged perivascular spaces in the mid-semioval was significantly greater in migraine patients compared to controls. Moreover, enlarged perivascular spaces in the mid-semioval area correlated with the intensity of white matter stimulation in migraine patients. We studied chronic migraine and episodic migraine without aura and found that in both types of migraine, the perivascular spaces were larger in the semioval center, Zhu said. Scientists hypothesized that significant differences in perivascular spaces in migraine patients compared to healthy individuals may suggest glymphatic disturbances in the brain. The glymphatic system is a brain waste disposal system that uses perivascular channels to eliminate metabolites from the central nervous system. Disruption of the glymphatic system would mean that the brain is unable to cleanse itself properly, leading to a buildup of waste that can be toxic to the brain. However, it is not known whether these changes influence or result from the development of migraine. Continued research on a larger group and long-term follow-up of patients will allow us to better characterize the relationship between structural changes and the development and type of migraine. The results of our study may help inspire larger-scale future studies to determine how changes in the brain's microscopic vessels and blood supply contribute to different types of migraine. Ultimately, this could help us develop new, personalized ways to diagnose and treat migraines, Zhu said.